So my name is Bessem Sayadi. I'm research manager in Nokia Bell Labs, and I would like to present some work that we started since 1.5 years in an European funded project called NGPaaS. So just to present the consortium, so it's a project with some customer like BT, Orange, and we have also some cloud provider like ONAP and some universities. And the most important thing that we built this project, so now it's more or less 1.5 years, in order to bring something that at that moment we find that all the thinking is based or coupled to Itsimanu. And we find that this logic, toward what we promised in 5G, like I think you know this triangle. So 5G promised that we need to support many use cases, and all these use cases have different requirements. At the same time, we need latency, some other need high throughput, and so on. Behind this scheme is we need agility in the system. So one of the solutions at that time, we find that this transformation of the network is done by what we call NFV. And at that time, NFV, so it is more or less based on VM based, where we have Itsimanu, and we have OpenStack behind. And more to bring this cloudification, if I can say, one thing that we adopted in NGPaaS, that the cloud is more advanced in web scale. So there's no need to reinvent the wheel. So our logic is to adopt as much as possible from the ecosystem, from the cloud, and adopt it to our business. And here comes to all what we call microservice, container, and all this brings the agility that we are needed in order to implement this flexibility in 5G. So for that, in the same time, I'm sharing a software network working group at 5GPP, and we submit this white paper where we try it at least to convey our logic, how we can adopt easily this web scale in our business. So the link is there. So this is nice reading. Then this is first option, first pillar, if I can say, be cloud native. Second one, it's to adopt what we call the platform as a service, in the sense that platform as a service, since when we started by analyzing OpenStack, it's seen like it's a IaaS model. And if we start by designing function where we have tight relationship with the infrastructure as a service, we are losing this flexibility. So we need to decouple the function from the platform. And at the same time also, we have many requirements from the vertical, since most important thing in 5G that we embark this vertical business. And this vertical business, they have different requirements from our telco business, in the sense that we need to offer the possibility to deploy on private cloud. We need also to adopt this heterogeneity in terms of infrastructure, and so on. So this is what we try to build, at least in NGPaaS, so is how to design what is the best platform as a service for the future. So here the first design, that first we need to design the function. I mean, behind the function there's a piece of code. Behind the piece of code there's some teams that are writing codes. And this function should not be designed tied to one target platform. And this is, for our business, is very important, since if one customer asks us, for example, he has a pass type A. So we need to have this flexibility to code once and deploy many. So this is what we start by designing, in the sense that the platform should adopt and should contain all the requirements in terms of services that needs to orchestrate and to monitor and to network all these VNFs on the top. And behind, we have all the function. It could be run, application, core, make, whatever we want, but we need to decouple this. And both combining design what we call the platform. So to do that, we will not adopt easily in the market. We have many options. Now we have OSM, we have ONAP, we have Kubernetes, we have Cord. So each one of this open source, they claim they can support all the use cases in 5G. So in order to not enter in that debate that ONAP is better than OSM or OSM is better than Kubernetes, okay. So what we try to do is to combine them. But to combine them, we need a model. And our tool is what we call the reusable functional block. It's not a microservice, it's not a VNF. It's something like a VNF, but where we have this feature that 3 functions, model-driven, polymorphic, recursive, and universal. And behind this terminology is very important in the sense that when you design a model at the service level, for example, when you want like to deploy a MBB service need a run service and the core service. The core service should run on a platform. The platform could be OSM, could be ONAP, could be Kubernetes. This platform could be deployed on private and edge cloud. So you see, we are separating the concern, the what, the where, and the how. So there's no need to combine them. And to do that, we are using this recursivity in the sense that by implementing this recursivity at all the layers, we are using the same workflow to deploy a service, to combine services, to design the platform, and to deploy the platform. So we are bringing all the use cases, all the flexibility that we need in 5G. So here is more in detail what is this tool that we are using, this RFB. So the RFB is, everything is RFB. It could be a script, it could be a VNF, it could be a database, whatever you want. We have 2 classes of RFB. RFB as a platform, for the platform itself, and RFB for the services. They are recursive, so here just a comparison compared to what we have in ETSI between network servers and the VNF, so it's one level. And also, as now we have this many platforms, so there's no more to have a centralized OSS, so we need to have a distributed OSS among all the platform. So here, an example. So all what I'm saying is implemented in NGPaaS. We have many POCs. So here is the first one that Cord 6, so it's the latest version of Cord. And you see that the Cord now is decomposed about this graph. So here is the graph of the platform Cord. And behind this, if we have a component more powerful, the component is swappable. I mean, I can replace one component by another. So this, we call this the blueprint of the platform. And in the POC, we started in the project by Cord 4.0. At that time, the deployment of Cord 4.0 it takes more than 3.5 hours. And implementing Cord 4.0 using RFB, where we are trying to decouple all the function, we reduce the time to 15 minutes. So this is something that we succeed to demonstrate it. Another platform, Kubernetes, also we follow the same thing. And what is the good behind this, that we are able to adopt easily what we have in open source, but adopt some telco grade patches. And here, for example, is the Kubernetes that we deploy for the run, where we have some feature like CPU pinning, NUMA, and so on. Many plugins. So we have here Calico, Flannel, and so on in the same blueprint, which is not the case when you use Kubernetes. We succeed also to make this exercise on OSM, latest version, 5.0. So we are decoupling all this. So we have this RFB. So here what we have, this our tool we call RDCL. This is what we call the edition view. Since most of the thinking now, people focus on the runtime. But before the runtime, there's some edition. So when we try to edit, so we can edit service, platform, and infrastructure. And when we combine these three layers, we can do whatever we want, as we show. So once we design the edition view of our platform, let's take, for example, Kubernetes here, it will be deployed on whatever you want. You can say, I want this graph to be deployed on this infrastructure, on this laptop, on this public cloud, private cloud, and we succeed to make, for example, one cluster from Amazon and the edge. In the same time, we deploy the core services connected to another platform, Kubernetes, running telco grade, where we have run services, and both are connecting at the service level. So the service, it comes where we call the BSS. Here, it receives only the intent from the vertical. The vertical expresses what he wants to see or what he wants to implement, and then we can deploy whatever you want. And here behind this, you can combine. I mean, for the run, there's some need to have more flexibility, more performance, so we can use Kubernetes. For the core, we can use Core, we can use OSM. We have another platform for monitoring. It could be used ALK, Prometheus, and everything is a platform. And all the platforms are connected at the service level to implement the end-to-end service. And behind this, here, for example, a slice at the end is only a combination of a service between platform. And what is also important, that all the components could be upgraded, could be versioned, and so on. So we call it platform dev for operation, so which is a generalization of the DevOps, in the sense, since now the NGPaaS operator can receive many functions from many vendors. So it's not DevOps, it's dev for operation between organization, between vendors, between third party, between open source, and so on. And this is what we call the dev for operation. So here at the end, the global picture. So it's all the layers here behind our platform. I mean, the function deployed on passes. Dev for operation also is a platform. The OSS is distributed among all the platforms that we see here. So now, where is the automation? So what we succeed in our POCs, that now we are facing to, how we can say, open source, inner source, closed source, and more we need to combine this. I mean, we as Nokia, we have some proprietary code, but there's no need to reinvent the wheel. So we need to combine our closed source or our inner source with some open source. And this is to be done by using this RFB. So we have this additional view that are already showed. Then to bring this flexibility about deploy on public, private, edge, and so on. So we need the processes, and here the processes are behind the OSS and the OSS and plugins, since the plugins, you can bring whatever you want as monitoring framework, automation framework, machine learning framework. So all this should be modelized. And at the end, the automation is only the acceleration of these two steps, the edition and the processes. So the automation, from our perspective, is an accelerator is one leg from the full picture. I mean, we are looking for the agility. The agility could be done by the processes. I mean, the process that you design in the platform, the healing, profiling, monitoring, alerting, and so on. All these are processes of the OSS that you deploy on the platform. Another pillar is the flexibility, since we have now multiple roles, vendor, third party, vertical, and so on. Many API, many platform, many sources, and multiple assets. We can combine all this, whatever we want, and the automation is only the third leg of all this. It's an acceleration for these two steps. For automation, we can find the NGPaaS, the blueprinting, since one key aspect for the automation is this blueprinting, since now the blueprint of this platform, and we see this trend now in ONF, for example. There's this exemplar platform, in the sense that we have some blueprint that they will be given to the vendor, that the vendor will give the function according to what the customer support as platform. Also, we can compose them. We have this RDCL, RFB, and also all this KPI that you are looking for, core deployment time, service deployment are enabled by RFB and RDCL. So this is what we succeed at the end of this project. And we have end-to-end pilot under construction with Orange and BT, where we combine the run, the core, on two different platforms, network, and we have two vertical, and we are combining all this in the same platform, using the same tool, the same workflow, based on RFB, RDCL. This is end of my talk. Question?
Any questions?
One question. So, of the different platforms, they are managed by the same Kubernetes, or
No.
they are different?
Two different Kubernetes. For example, for the run, we have this kind of template or blueprint. We have Calico, Flannel, SCTP, CPU pinning, NUMA, and many other. And for the core, it's another Kubernetes where we have only Calico. It's two different platforms, two different blueprints, and two different services exposed.
Is this in open source? Is there an open source implementation?
For RDCL, yeah, it's an open source. Yeah.
And where do we look for it?
I think we have a GitHub RDCL. But the version now, it's not the same as we are using now. It's not yet released, or what we are doing.
What technologies do you use for building the microservices? Apart from Kubernetes, what other technologies? Using the same technology, the same framework for the different platforms for the development?
This comes to the question that we need to design the function completely independent from the platform. Now, if you look to ONAP and OSM, the control plane could be running on Kubernetes, but the data plane is still VM based. I mean, the service-based architecture, what we have in 3GPP on the core, cannot be supported now. So I think, well, for the moment, no. We are using only natively Kubernetes for this. And behind also there's a lot of other ecosystem from Swarm and so on. It's not only Kubernetes. There's a lot of many open source.
And you use Docker, right?
Yeah, based on Docker, yeah. Any other question?
All right.
Okay, thank you.